Hi! So today's going to look a little different than other days. I'm not actually teaching you anything new. You're just practicing what you already have learned, or hopefully have learned. And then I'm just going to be here to support as needed. So you can see that I already filled in my answers. This is 142 to 145. The only times that I'm going to put breaks and ed puzzles are between the questions so that you have a natural place to know where to skip to. So this first question, from 1998, we're taking it way back. I feel like I should be on a radio program right now. But in 1998, this is from the AP Calculus exam that year. And this graph was given of velocity. And then the same table that represents this graph was given. And so I'm going to do my best to not mess around with this so much so that you can check your work. So right now you should be able to see A and part of B. I'll move that very soon. In this, it says a car is traveling on a straight road. This stuff in the beginning is actually pretty important. If a car is traveling on a straight road, this is where you're saying nothing crazy is going on. This is going to be what we expect it to be. This function should be. We can see the velocity is continuous, which means the position would also be continuous and differentiable. And we can see that we have a table going on here. Nothing crazy, smooth curves. This is all nice. If I go to the questions and I go up, you can look back and forth, but I'm going to try to keep these here so you can see everything all at once to check your answers if needed. During what intervals of time is acceleration positive? In that first one, acceleration is positive when velocity is increasing. And I know that because acceleration is the derivative of velocity. So I would actually put that relationship there, that a of t is equal to v prime, and acceleration is positive when velocity is increasing. I would do that before I did the intervals or figured out anything else, because then it's easier to go back and look at the graph and say what is actually happening and when is velocity increasing. So I did that, and you should have gotten two different intervals. Velocity is increasing. I said I wasn't going to go down, but I'm going to for a second. Increasing up into the right here, we can see it. On those two intervals, 0 to 35 and 45 to 50. Oh, let me move a little more. If I'm finding average acceleration, average rate of change of velocity, that would be average acceleration. So I'm saying v of 50 minus v of 0 over 50 minus 0. Make sure that you show that whenever you're doing your work. Don't just show up with a blank answer. They call that a bald answer on the AP exam, and it's not accepted, particularly now when we're doing work and we're not in the same classroom or whatever. Make sure that you're showing as much work as you can, but without overdoing it. So you don't have to explain everything, just showing your work is enough, and then at the end indicating units of measure. This is plenty of work to get you full credit on a problem like this. So this is average velocity, and or average acceleration, I'm so sorry. Average acceleration is the rate of change over an interval of time of velocity. And if you want to make sure that you're setting up the right equation in the first place, the units are necessary to indicate in order to get full points, but it's also a good thing to just know that you're doing this correctly. You can see the numerator. If I do v of 50 minus v of 0, the units for velocity are feet per second in this problem. The denominator is just 50 minus 0. That was just seconds. Feet per second makes sense as a unit for acceleration. Some people automatically, if you're in physics a lot, start putting meters per second. Make sure that you're careful in whatever is given in the problem. If it says feet per second, or if whatever units are given, those are the units you use throughout. So I've got feet per second, if you want to change this to 1.44 feet per second squared, you can. You might be looking at this and saying, she didn't use 3 places after the decimal. I thought that's the accuracy we need to have. If you do 72 divided by 50, 1.44 is the exact answer. I'm not rounding or truncating anything. That's why I can stop it with only 2 places after the decimal, because 1.440 means exactly the same thing as 1.44. And the next one, find one approximation for acceleration. I said that weird. Acceleration is the derivative of velocity. To approximate a derivative, anytime derivative is slope of the tangent, to approximate, we use the slope of the secant. So this is where I'm picking a point to the left and to the right of 40, and you can do this from the table up above and find v of 45 minus v of 35, 45 minus 35. There are several ways that you could do this. You could pick v of 40 and the point to the left, v of 40 and the point to the right. Like, you could do this different ways. This is really important to write down how you did this exactly, because this is where the first point usually comes from, is just using this difference quotient in some way. Again, this one is exactly negative 2.1, which is why I didn't have to go 3 places after the decimal, but make sure that you're always doing that. Always the accuracy in your final answer of 3 places after the decimal. Feet per second is the numerator, because that was what velocity was given in. The denominator is just in seconds. Or you can write feet per second squared. Either one, it means the same thing. The next one, if I want to know, is the speed increasing or decreasing? Speed is increasing when velocity and acceleration have the same signs. Speed is decreasing when velocity and acceleration have opposite signs. So you need to compare those two. So you need to find the velocity at 40, which was just given in the table or in the graph of 75 feet per second, but you don't have to write that here. A of 40 is negative 2.1 feet per second squared, approximately, because that's what we found up above a second ago by finding the rate of change between 35 and 45. I can see because velocity is positive, acceleration is negative, they have different signs. This is how you would write this. And I said v of 40 is greater than 0. You could have put is positive. A of 40 is negative or less than 0. Speed is decreasing at this moment at t equals 40. Okay, one down. Let's go on. We can do this. Here's another one. So we're moving right along, going through the years. I feel like this is like calculus through the ages. We're up to year 2000. 2 runners, A and B. This problem is actually pretty straightforward. So 2 runners, A and B, are run on this racetrack. The graph consists of 2 line segments, blah, blah, blah. We can see this, but meters per second is what the velocity, like the units for velocity. This is what velocity is measured in. And that's for runner A, and for runner B also, meters per second. We have a graph for runner A. We have an equation for runner B. Writing that somewhere in here, and I know that that says that. It says runner A over here, but it's really little, and you don't want to mess this up. Velocity of runner B. Here are the answers if you just want to compare those. There we go. I think I've got everything on here. The only thing that's missing is this says meters per second over here. In A, if it's asking me find the velocity of runner A and the velocity of runner B at 2 seconds, this is simply finding the point, because the velocity of runner A, this was the graph that was given. So I go over to 2 and I find out what is the point, what is the y value. At 2, I can see that there's just a line, and it's not really clear what the y value is. It's somewhere around 7, but not quite at 7. And so what you need to do is figure out what is the equation for this line. You've got 2 points. You can figure out the slope. You can figure out the y-intercept. Pretend you're back in Algebra 1, and then say rise over run. You could say is 10 over 3 between the 2 points. That's where the slope is coming from. The y-intercept is 0. If I want to know what the function value is at when x equals 2, I'd say 10 thirds times 2, and that's where I'm getting 20 thirds meters per second. So this is just substituting in to that graph, not even substituting, looking at the graph and then finding the equation of that first line, the first part of the piecewise function. For the velocity of runner B, we had this as given as v of t is equal to, and then up above was 24t over 2t plus 3. I just put the velocity, I can speak, there it is, the velocity at B, or of runner B, at time 2, and substitute it in. And you get 48 over 7. Make sure to include units. This would be meters per second. If you were very sad because we didn't really do calculus on the first one, the second one we get to. But it's not crazy calculus. It's just thinking through this process. So this one says find the acceleration of runner B at time t equals 2 and of runner A. Sorry, I missed that part. The acceleration of runner A. Let's think about this. The graph of velocity is given. To find acceleration, I take the derivative. The derivative of velocity is also known as the slope of the tangent. So what I'm going to look for is the slope when time is equal to 2. Go up above here, the slope of this line. We already figured out the equation of this line. The slope is 10 thirds, or you could just do rise over run again and find 10 thirds. That's where that is coming from. If you're thinking about units, and we just said rise over run, going back up again. Meters per second was my rise, my change in y. My x is my seconds. Meters per second over seconds is right here, which is also my meters per second squared. Same idea. The acceleration of runner B would still be the derivative of velocity, but you have an equation this time. So this is where you remember what the quotient rule is. What is the quotient rule? Bottom times the derivative of the top minus top derivative of the bottom over the bottom squared. If you mess something up in here, most likely people switch these two, the top and the bottom, and they switch those two things around. We haven't done the quotient rule in a little bit, but this is a good reminder. Bottom times the derivative of the top minus top derivative of the bottom over the bottom squared. You get this answer of 72 over 42, or 1.469, 3 places after the decimal, meters per second per second. So much calculus, so little time. Just kidding, we have time. Okay, this is on 144. So on 144, this one is a little bit more complicated just because it involves trig, and there are a couple things that are easy to forget in here. So in the first one, it says, what is the acceleration of the object at time t is equal to 4? So if you're given velocity and you want to find acceleration, and by the way, this initial position, x of 0 is 2, does not affect anything yet. It will at some point soon, but not yet. So you can really just ignore that. This is where it says partial. This is used in a part C or a part D of the problem. Okay, so to find acceleration, we're taking the derivative of velocity. And so to find the derivative of velocity, we've got sine of pi over 3t. The derivative of sine is cosine. Leave the inside alone because this is chain rule. Wow. Times the derivative of the inside. The derivative of pi over 3t is just times pi over 3. This is the coefficient. Okay, to find 4, substitute in 4. When you're finding cosine of 4/3 pi, what you're really doing is finding the cosine of pi over 3, which is just 1/2. And you can make triangles. You could do this lots of different ways, but you could use the unit circle. This is 1/2. Remember, at 4/3, that would be 0 here is pi here, a little bit past. Tangent is the only one that's positive, which means cosine is going to be negative, times still pi over 3, because of the chain rule. Again, negative pi over 6. This is the acceleration at time is equal to 4. The most problems that you'll see right now will have you doing units in some way. That's become a much bigger deal in more recent years rather than in 2002, where you have to indicate units of measure. In this one, you can't indicate any units of measure, though, if there's none given to you in the problem to begin with. Okay, this one, don't be scared. You can do it. If you need to give yourself a pep talk now that says you can do it, you can do it, you can do it, or I can do it, I can do it, I can do it, if you're talking to yourself, do that. The first thing that I want you to know, and the part that's like really the calculus related, like this is important for me to know right now, is just, do you understand the question? If velocity is decreasing, that means its derivative will be negative. Velocity is decreasing. The derivative of velocity is acceleration. So I'm looking for the places, is acceleration negative? And this time it's over an entire interval from 3 to 4.5. If speed is decreasing, that means acceleration and velocity will have opposite sides over the entire interval. And so this is the process I went through here. I'm going to slide up my work and do my best not to block it. I don't know why I switched color pens, because some of these things relate to one another. So the first thing, if I want to know if the velocity of the object was decreasing, I needed to see if acceleration was negative. And over that entire interval. So this is the work on this side. I found velocity, which I could have really saved myself some time and just used what I found up in the first problem in part A, but whatever. Here is the derivative of velocity, acceleration, and I set that equal to 0. The reason why I'm setting it equal to 0 is I just need to see, is there any place where acceleration changes signs on this interval? Is there a place where I will see where acceleration goes negative to positive or positive to negative, because that's going to affect my answer. Here I've got cosine of pi over 3t is equal to 0, and you might say, I don't know what to do there. Well, think of the places where cosine of some number, so cosine of a question mark, equals 0. I know that that happens. I always think of this curve, but you can think of the unit circle or some other way. I think at cosine of pi over 2 and 3 pi over 2, that's when I get 0. But the inside wasn't just a question mark, it was pi over 3t. So I set pi over 3t equal to pi over 2, pi over 3t equal to 3 pi over 2, and then I get that the time that acceleration is 0 and could be changing from positive to negative or negative to positive is at 1.5, which is not on this interval, and at 4.5, also not on this interval. So here, acceleration, we knew up above that acceleration, or I think I have this written somewhere down here. Yeah, acceleration, or v prime of 4, we found up above was negative pi over 6. And you could have just said c part a, you wouldn't have to do that again, was negative, which means on that entire interval from 3 to 4.5, acceleration is negative. Velocity is also going to be negative, but I don't know why. I didn't write this yet, but I can. So velocity, I just tried sine of 4/3 pi, and I figured out at 4/3 pi, velocity is negative. But to find the entire interval, you actually have to see, is velocity, is there a place, v of t is sine, I'm running out of room here, where is this equal to 0? Oh, I started to write this. Where is this equal to 0? And what I would be thinking is, well, this could be at 0, which is not on that interval, at pi, so the inside, pi over 3t, could equal pi, and then at 2 pi is the other place where sine of 2 pi, so I'm going to say 2 pi is equal to pi over 3t, and see if any of these things happen on this interval. This one, if I multiply both sides by pi over 3 in order to get rid of this, 3 over pi, I would just get 3, which is at the beginning of this interval, so velocity does not change signs there. For this one, I would have to multiply both sides by 3 over pi, and I would get 6 is equal to the t, which is not in that interval, so I know that velocity is the same the entire time, but this could be a good thing to also put on here. Velocity at 4, if I try this, I get a negative value, and now I can say, okay, I know velocity is negative on this entire interval, acceleration is negative on this entire interval. Are these statements correct? Well, statement 1 is correct, because acceleration is less than 0 for the interval, the entire interval. If acceleration is negative, velocity is decreasing because acceleration is v prime of t. They're the same thing. So I'm dropping a whole lot of knowledge right here in my solution, and you should be too. You should be saying a of t is equal to v prime. It's showing that you know the connection between acceleration and velocity. And I also know that velocity decreases when acceleration is negative. For statement 2, I would need, for an object to be decreasing, velocity and acceleration to have opposite signs, but they don't. Acceleration and velocity have the same sign, so that means speed is increasing. So I'm just saying this is not correct. For speed to be decreasing, I drop some knowledge and say v of t and a of t must have opposite signs, but these ones, they're both positive, meaning the same signs. Whew, that was a lot. Here's the last one, check in 2003. This makes me feel really old, but I'm not gonna lie, this is when I graduated, so this could have been my problem. Do I remember? Nope. But I did graduate in 2003, and I did take the AP exam during my senior year. And I remember thinking after the AP exam, I have no idea what I was doing on that. And I think I got a 4. And so what I want you to do is when you come out of that, regardless of what your score is, I want you to come out and be like, I knew what I was doing. When they asked me those questions, I actually understood. This is my goal. And I really hope for a good score for you too, because I want good things for you. Okay, a particle is moving along the x-axis so that its velocity is given by this. So this one's a little interesting because I could use my calculator and say the acceleration of a particle at time t equals 2 and do it that way because I end up getting a decimal at the end. But if you want to practice the product rule, this is a good time. So first derivative of the second plus second derivative of the first. So first times the derivative of the second plus the second times the derivative of the first. I said that weird the first time. And then you substitute in 2. because acceleration is the derivative of velocity. So making sure that you indicate that connection there. There aren't any units, so you don't have to put that. And then once you answer that question, when there are multiple things being asked in a question, often if I'm answering them on an open-ended question, I do that and I'm like, okay, I got the first question. Let's do the second one and make sure that you've gotten all of the parts of this problem. Speed is increasing when velocity and acceleration have the same signs. We know that acceleration at t equals 2 is approximately 1.55, 1.588, 1.587, depending on whether you truncated or rounded. Both answers are acceptable. You don't have to write both, by the way. Just choose one. We know that acceleration is positive. What we need to know is velocity. So if we substitute in 2 for velocity, and we get this, we get negative 2.727. Right now, I can say velocity is negative and acceleration is positive, therefore speed is not increasing. And you might even say opposite signs, B of t and A of t. So we said speed is not increasing. You could say decreasing here too, but it's asking about increasing, so I'm just saying no, it's not. And then yes, I explained that because I said velocity and acceleration have opposite sides. One more explanation. Find all the times when the particle is changing directions. Here, I'm going to try to move it from behind my head. The only thing that you're missing from behind my head is this says negative to positive. So then if you want to just check your work, you can. Okay, when a particle changes direction, left to right or right to left, I have to think about, well, what does that mean? When is a particle moving to the right? A particle is moving to the right when velocity is positive, left when velocity is negative. So you're looking at the places where it could possibly be changing. So in this, I'm going to find when could velocity be 0 so I can set up this chart. Here's my velocity. If I set up and find the 0, I'm finding when could this first part be 0 or when could this be 0? Because I know any number times something and I get 0 is still going to be 0. So negative t plus 1, I can see this would be at t is equal to negative 1. That's not on the interval from 0 to 3 as given, so I don't have to worry about that. This one, you could use your calculator on this one too because we end up with kind of a crazy answer. But if you were being ambitious and you wanted to say, I want to know when sine of t squared over 2 is equal to 0, you have to be thinking, well, when is sine of anything equal to 0 on the interval from 0 to 2 pi? Because that's just normally the ones that we use. At 0, which if this whole thing equaled 0, that would not be on the interval of 0 to 3 where 0 is not included. So not 0. Then I can try at pi. So I can say sine of pi is equal to 0, sine of 2 pi equals 0, which means the stuff on the inside, t squared over 2, could be equal to pi. T squared over 2 could be equal to 2 pi. And I can see, I already said before that t equals 0 was not on the interval. T could equal the square root of 2 pi or the square root of 4 pi. Square root of 4 pi is not on the interval from 0 to 3. Square root of 2 pi is, hold on, something happened. And then over here, I think I wrote the wrong one. So if you did that before, let me just make sure. Square root of 4 pi is 3.5. This should be 2 pi. So sorry about that. So if I do the square root of 2 pi, I wrote this answer correctly, but then I didn't write this one correctly. I don't know what was up. Pick your favorite number from 0 to the square root of 2 pi. Same thing over here. There we go. Pick your favorite answer from 0 to 2 pi, from the square root of 2 pi, square root of 2 pi to 3. Pick your favorite, and then figure out negative or positive in this interval. So, I don't know. If you pick 1, for instance, and you substitute 1 back into velocity, you will figure out that velocity is negative, which means the particle is moving left. Pick something from 2.506 to 3, maybe 2.7. And then you'll figure out that velocity is positive, moving right. So your answer then would be, at t equals 2.506, the particle is changing directions as v of t changes signs. And I just added from negative to positive. That's it. Thanks so much for working. This was a tough day, but you're tough too. I really appreciate you. If there's anything you need, please let me know. Thanks so much. Bye.